Hello everyone. Let's start. The topic today is the main topics is the RAID. What is the RAIDs? What types exists? Virtual machine and Docker concept. So we will start with RAID definition. What is used for and what types we know. RAID, this is a so-called array of the hard disks or HDD or SSD, which the main purposes of this array is to increase performance, so-called performance improvement, or increase data security for cases when one of our hard drives will surprisingly die. Exist two kinds of RAID arrays. Hardware RAID, this is when we have a special controller, so-called RAID controller, and software RAID. Software RAID is very popular for small servers, for personal computers. Hardware RAID mostly used. Oh, yes, have to send. Hardware RAID used for big servers and for some systems they have requirement that if you want to install some kind of software, some kind of operating systems, if we talk about enterprise operating systems, they have requirements for hardware RAIDs. These systems, for example, can work only with hardware RAIDs, and moreover, they work only with special types, special models of hardware RAIDs. Here describe the most popular RAID types and what it's about, how it's differ. RAID 0, this is situation when we have, for example, two hard drives. We can have more, but the main idea that we have we want to get the hard drive of much space than we have by every single drive. For example, we want to get a hard drive with volume, let's say a couple of terabytes, and we know that today we have no drives with so much capacity. We have drives, as I know, like maybe 10 terabytes maximum, maybe more, and it's the price of these hard drives is high. But if we want to get volume like of maybe hundreds, thousands of terabytes, we can use this drive approach. So we collect together and include in the single RAID. What we get? If we have some system, for example, some storage, we can work with this storage as with single drive, very big drive. But if just one of these drives will die, we will First of all, we will lost some data because, as you can see, some part of data store situated here, another part here, and if this drive is absent, so we cannot continue to work. And this is a bad, this is disadvantage of this RAID type. But from another, this approach have advantage. If we want to read some data, or if we want to write some data to this kind of RAID, we can in parallel read from both drives, and also we can read and write from both drives in parallel. And if we have some limitation by speed, by every of drives, we can read by twice the speed of reading we have in 2 times more, and for writing too. So we can increase performance, but we decrease our security. We have in 2 times more speed of read and write, and we have in 2 times less the security. If some of one drive is dead, we lost our data. Opposite a little bit, this is RAID 1. Also, it's called mirroring, because if we write data to one drive, we also in parallel write this data to another drive. So in this situation, if one of drive is dead, every data, so all data is stored on another disk. If disk 1 is dead, this is not problem. We have every single file on another drive, so this is not problem. But we have to spend a lot of money to buy 2 disks. So if we want to get like 1 terabyte of data, so we have to buy 2 hard drives. Each have to have volume of 1 terabyte. So we have less volume, but we have increased of security, and also we have increased the read and write speed, because we can also read and write from both hard drives simultaneously. Maybe more than other type of RAID. This is RAID 2, and this type of RAID uses so-called Hamming code. You can read a lot about this code, but in shortly, this code help you to use special additional drives to repair data if you lost one of 3 drives. So in this situation, we have one part of data, second part of data, third, fourth, and also this piece in this situation AP1, AP2, AP3, and these 3 pieces help us to repair if one of these drives will die. So A1 or A2, A3. So this is not full mirroring, but this is kind of it. And the principle what is used is all described in Hamming code. So it's little bit sophisticated, and by this reason, this RAID is not very popular now, but some years later, some people use this RAID 5. This is another. Also exists, of course, exists RAID 3 and RAID 4, but I have not described it here because it's very not popular today to use these drives. So the most popular today and what I usually met is RAID 0, RAID 1, RAID 5, and also some combinations of these RAIDs I will talk about on the next slide. So RAID 5, this is kind of between approach between RAID 0 and RAID 1. Here we have not full mirroring, but we have some general parts stored on the hard drives and the additional part. If some of these drives is absent or died, we can used by other free drives to repair this data. So we have 4 drives. It's not fully mirroring, so we not spend lots of space on every drive, but also we have some security advantages. And also RAID 6, this is kind of modification of RAID 5, but we have 2 drives which have additional repairing parts of files. So here we if drive, for example, if disk 2 will die, so we can use these 2 parts to repair. But also, like in RAID 5 situation, as I know, if 2 drives here will die, we can use these 2 drives to repair A1 file, but this is based on the special algorithms. So to repair, we will have to spend some time, but it's possible. This is not a popular type of RAID 2. And mixed RAID, how to describe. If we talk about RAID 1.0, this is mean that we have 2 RAID 1 in RAID 0. As you can see, like one RAID 1, another RAID 1, here is full mirroring, and here is full mirroring, and it's all included in single RAID 0. And another situation, RAID 01. Here's 2 of 0 RAIDs in RAID 1. By the same approach, you can imagine RAID 50, 05, 01, 15. Some of these modifications more popular, some less, but this is usual situations. So it's all about RAIDs. You have assignment about this topic, so you will try to touch this and to create your own software RAID when you can test how it works. As I remember, in the assignment you have to build RAID 1, the full mirroring. Okay, another probably the main topic of today, this is virtualization approaches. The most popular approaches, this is virtual machines, hypervisor, like here the main 2 types of these hypervisors. First type, when we have hardware level, hypervisor level, and virtual machine level with Guest operating system on each virtual machine. And another, this is the same, but also we have host operating system. I will talk about this in details. First of all, examples. Probably some of you already work with kind of these types of virtual machines, but maybe you're familiar with VMware Workstation software and VirtualBox. This is all about type 2 hypervisor. When we have our computer with host operating system and we install a VMware Workstation, for example, this is our hypervisor, and we run virtual machine inside this hypervisor. And type 1 examples, this is VMware ESXi, Microsoft Hyper-V, Citrix, and KVM. Also exist much more examples of these types of hypervisors. These hypervisors have more performance because we have not host OS level layer. We doesn't spend some performance resources for this host operating system. And let me to show you some examples. For example, I have VirtualBox. How this application looks in Windows. You can install. It's free and open. My VirtualBox is made by Oracle, but also exists the open VirtualBox version. And for example, I have virtual machines. You can, if you want to create new virtual machine, you press create, write some name. You can select which operating system you're going to install inside this virtual machine, but actually this is just some special settings of hardware. You have to really install it then. So I can check how much memory, so-called RAM, I will install. I can choose I will create new virtual hard drive, or I will use some existing hard drive. I will choose that I will create new. And here some types of virtual images. It's depend of compatibility between hypervisors. Some types we can use in VirtualBox. Also, we can export and use the same hard drive in VMware Workstation. But here it doesn't matter. I can create that it have dynamic volume, and it will become larger and larger from the time. Or I can fix the size, and when the maximum will reach, the virtual machine will say that I have no more space, so I will have to do something to solve this problem. I will check that I will create a virtual drive with 32 gigabytes volume, and here I have my new virtual machine. If I will run it, probably I will have some error that it's asked me about loading drive. Also it looks like it asked me to choose some optical drive to install something inside this virtual machine. if I will press cancel, have to, yes, it told me that it has no bootable medium, so I have to install some operating system inside it. I can choose ISO image and install something inside this virtual machine, but probably usually it takes a lot of time. I can show you also some properties. If I want to change something, I can do it. Like I want to increase the memory volume, I can change the processor's CPU count. I can do it. Also, lots of properties connected with here with network. This virtual machine can operate like in so-called NAT mode when it can get access to the internet if my general machine have access to the internet, but it will not have some external IP address. I can add some COM ports, USB. I can pass through some USB from my general machine. So if I insert some devices in my real computer, I will see it in virtual, and it can operate like I insert it inside virtual machine. Also, I can set some shared folders between my general and my virtual machines. And here's something about interface. So, for example, I can show you also how it looks when something is installed. So I can run any operating system inside my main operating system. For example, now I am in Windows 10, but I can run CentOS. As I remember, it's version 7. I can run any virtual machines in the same time. So this instrument very helpful when you want to work with different operating systems, with different computers in the same time. When you want to test something, or you just want to learn how something works. So here I have Ubuntu, and here I have CentOS, and I can try to remember password. uh, should be always boxes, but it doesn't correct. Okay. This is doesn't matter a lot. So how it's look? I can turn off like from the external button. I can turn off it's like in more suitable way. Okay, this is what about the type 2. When we have my computer hardware, my so-called host operating system. Also inside I run some application, and this run some virtual machines which have some guest operating system, and inside this guest operating system I can run my applications. Another way of the type 1. I will try to show now. I have to connect. Here we have some server which have not host operating system. So as it doesn't have host operating system, it have just a blank terminal, blank console. I can try to show you how it looks. So now I'm in the same network with this computer. Oh yes, I am in. And here is example of E6i server. It's free, so if you want to check something, you can use it too. And also it have more beautiful interface with fair client, and it looks more friendly. Here we in. So it's little bit similar. We have our server, or we can see how resources is loaded. If we want to see some CPU, how it work, and we can also see the same situation by every of virtual machine. Mostly of these machines are without graphic interface, but we can log in each of one of these virtual machines by special so-called hypervisor interface. And all these virtual machines are running on this server. You can see settings, memory, CPU, so everything look like similar. Options, resources. Also, you can set up some storage, so you can add some internal hard drives. You can add some storages from the external. For example, here is the network file system, and how it look like. If you want to create new virtual machine, you can just create, type a name, choose the storage where you will store the hard drive of this virtual machine. Choose the type, Windows, Linux, or other, the type of virtual machine, how many network connections you will have, and virtual disk size. So mostly the same. Also, this server has a web interface, but it's very I don't know, it worked not perfect, so I prefer to use this client. The internal, also you can try to work through the SSH interface through the console, and it has some commands. Some it have, some not. For example, it doesn't have Midnight Commander, and this is special type of operating system. So if you want to install some additional packages or some additional software, it's not easy to do because it have to be supported by this operating system. And another case, also what I wanted to show you today, this is probably the newest approach, so-called Docker software, Docker approach. When you can see, we also have hardware layer, we have host operating system layer, but additionally we have Docker engine, so kind of hypervisor layer here. Also we have some binaries, libraries, and application. Why we need this? Docker is kind of variation of type 2 hypervisor, but we doesn't use the full Guest operating system to run our application. We use only special binaries and libraries, only these libraries which we need. And we doesn't use full Guest operating system. So we kind of use less resources. And also we can set some type of environments for each application. So we think about what we need and what we doesn't need. And I want to show you some examples on another screen in a minute. So here on another computer, I have Ubuntu here operating system, so it's easier to show something. Docker have lots of documentation, lots of examples, lots of description about what you can do, and it has let's see, probably get started as usually some popular software has. Here you can read about how to install Docker on your operating system. You can install Docker on Windows, you can install it on Linux or on Mac. The main concept is about if you want to run some application, you doesn't need to run full operating system for this. You can just collect some libraries and environment settings and run it inside so-called container. So here what I talk about, here is about installation. I already installed Docker, so I can check Docker more. Can try to make the font larger. Oh, a minute. Work. Okay. I think you can see Docker V. So I have installed Docker version 19 and show you some example. here is kind of how it works with a default application. If we want to run, we just run docker run and the name of so-called image. Image, this is some entity which have application inside. But as I know, this application just print this message and some text. We can see which images are running. With command docker image class. So I have running of this image only. Which container I have? So I have only one container for now. I'm not sure if I want to stop work of container. Docker. Let's see. Docker run, docker. No such container. Docker. Okay. So also I want to make this example through these steps. Here's description how to create your own container. So to create your own container, you have to just create folder and put 3 files with settings of the future container, and this is what you need, everything that you need. So let's try. I will create the directory test docker. Test docker. Okay, I'm inside. And I have to create a Docker file called Docker file. I will use the text editor Nano, and I have to insert this inside. Let's see what it's about. So we have to describe which environment variables we use. So here is environment variable world. Here are some settings for, as I know, it's for application which we will run inside this container. Just paste this inside this file. Can check. Yes, everything is here. Second step, we have to create 2 more files, requirements, txt and app. So we'll create requirements. and just put inside these two lines. It's talk about which, as I know, about which packages command and output from Flask impact Flask. It has to be about which packages we will need to run our application. And actually the own application file have it will use Python language. So just insert and what it will create. So it's import Flask and Redis distributions, operating system and socket. So here's HTML part. So just so looks like, oh, probably it's yes. It's just this page has to be as a result. The next step is building the application. Let's check that we have everything. Yes, app, Python, Dockerfile requirements, 3 files. Now run the build command. I can just copy this. So now it's downloading some Python packages, and through pip, this is Python installation packages manager. So what it downloading? It downloads Flask as described in requirements txt file. Also, it's some additional. Looks like Flask asks to download some additional packages to work, and it downloaded two. Redis. So we have some deprecation. Okay. Where is your build image? We can check what now we have. The same 3 files, but Docker image. Yes, we have additional 1 and 2 images. This looks like old. This looks like created just 58 seconds ago. Okay. The next. Proxy servers can block connection to your web application. I hope we will not get this problem, but if we will get, I will return back. So we will run our image with command docker run. Here we show which port. So we map a port of our host computer to the port of our image. So it looks like our image have kind of web server inside, and we will access this port by our port 4000. So let's try. It looks like running. Have to check. Yes, it looks like everything is fine. Use sudo command in a shell to view the same content. You can use it too. Looks like everything works for now. So it just prints the whole world, which we can see by code of this page. So we just print this text. And if we want to stop, we just have to press Ctrl+C. Yes, now it's stopped. Also, we can run it in the detach mode, so it looks like we will not so we can continue to work in our console, and we can see which containers are run by command docker container was. Here our application. If we want to stop, we can use the command docker container stop and container ID. Our container ID is here. Just insert it. Also, what we can do with our image, we can share our image. The Docker, this is more than just application. It has kind of infrastructure. And as I remember, it will open. I will try to log in with my I'm not sure if I remember my password. If I don't, I will have to reset it. Okay, let's see. Docker login, yes. We will. 1 minute, I will try to reset my password. Oh, this is j-avdeev.com. Kind of the same situation with Vagrant software. It have the cloud platform with lots of images of so-called Vagrant boxes. If some of you have started assignment number 1 from DevOps course, you have see this. Okay. will try to repair my password. Okay, almost ready. Okay, let's try one more time. So you can sign up too. And here's my previous, looks like the same test containers which I've made a couple of years ago. I doesn't use Docker a lot, so it's just for vacation purposes. Okay, looks like I have to log in to the console. No. Okay, I'm in. So we have to tag the image. Looks like we have to make some name of our image. User repository, no. This is optional but recommended. And how to take it? Image is no. So let's try. I will copy but then edit. So my username is here, and repository. It's like also I have repositories. Let's call it test. And we'll try no such. I have to use the real image name, and name was test docker. No, from demo no such image. Image like test. Oh, yes, the name was friendly hello. Friendly hello. No. Docker. Oh, here is Docker tag friendly hello. Username. Get started. Part 2. Okay. And now we can run Docker image to see your newly target image. Okay, Docker image less. Yes, now I see. Looks like copy of my image, but actually, yes, I did the same. So this is just the same image with different tags. And publish the image. So repository and tag. Looks like everything is right. And to finish, we can pull and run image from the remote repository, like if we want to take our results from the server. So the command looks like this. Probably I can just copy. Oh, it's already running. And the host name is ad5c. It doesn't show here. Okay. So that's all about the introduction to Docker. I'm not sure will I continue with another. So if you're interested, here is, as you can see, very good explained steps of the main Docker possibilities, capabilities, what it affords, what you can do with this instrument. Probably I will create assignment, laboratory work based on this or this similar instructions. So here you can put some additional properties of your environment of application which you're going to start. Also, as I know, you can create some interconnection between your containers. I'm not sure that it's shown here, but it's possible. It's in the cluster. Okay, here is an example with the more sophisticated application. So I think it's all what I wanted to show you about Docker, about the virtual machine and hypervisor. Maybe I will add something additional on the next lectures. The topic in the next time will about GitLab application, which also use some capabilities of Docker application. GitLab, this is application system management software which help you to develop some applications, and it use some instruments from Docker too. Not usually, but in many cases. So this is all what I wanted to show you today. So that's all. Thank you.